Today, let's talk about some A-level stats and in particular, independent events. And you may have been told about this kind of result here. So if events A and B are independent, it means that when you times the probability of A with the probability of B, you have to get the intersection probability. So a good example of this situation, let's say we've got a Venn diagram like this. Notice how the probability of A is 0.16 plus 0.24, so everything inside the A circle, which gives you 0.4. And again, notice how the probability of event B occurring is this number plus this number, so again, everything inside that B circle, and that's going to give us 0.6. And then notice if we do probability of A times by probability of B, you get 0.4 times 0.6. So we get 0.24, which happens to be the one in the middle. So therefore, this tells us that events A and B must be independent. My question is why? Why is it true that when you times those two probabilities and you get the intersection, why does that mean that those two events are independent from each other? Why? So let's think about this word independent. If two events are independent, it just means they don't depend on each other, right? So as an example, let's say event A is the event that it rains, and let's say event B is the event that I hit a bullseye when I throw a dart. Now, if I hit a bullseye when I throw a dart, as long as that does not affect the chance of it raining, then those two events would be called independent. So we'll kind of resort back to this example. So we'll call A the event that it rains, and we'll call B the event that we hit a bullseye when we throw a dart. Now I've just copied out the Venn diagram again, and I've actually just noticed really I should be correct. I should really put the probability of the outside here. So there's a 0.24 chance that it doesn't rain and we don't hit a bullseye. Obviously just doing 1 minus these three numbers here to get this one. Now let's just say, first of all, I'm going to throw a dart at the dartboard and I'm going to see if that affects the chance of it raining. So step number 1, we go to the dartboard, we throw a dart and we hit the bullseye. We successfully hit the bullseye. Now the way that I like to think about it in terms of these Venn diagrams, if we've hit the bullseye, where could we be in this Venn diagram? We've got 4 compartments, this one, this one, this one, this one, 4 different regions that we could be inside. We've hit the bullseye. Which regions could we be inside? I mean, we can't be inside this one because we've hit the bullseye. We've got to be inside B. We can't be on the outside. So it's either this compartment or this one. So if we've hit the bullseye, we are trapped inside this red circle here. So now we can kind of forget all of this rubbish here because we've hit the bullseye. We are definitely inside this circle. Now the next step, right? We've hit the bullseye. Given that we've hit the bullseye, which we have, right? We've hit the bullseye. What is the chance now that it rains? So we're definitely in one of these compartments here, but what is the chance that after we've hit the bullseye, it is now going to rain? Now, in order for it to rain, we need to be in this compartment. So again, we've got 2 choices, either this one or this one. We want it to rain. This number is inside the rain circle. So it's going to be this number out of the total of the B circle. So the probability that it rains, assuming given that we hit the bullseye, is going to be this number out of the total, which turns out to be 0.6. So 0.24 over 0.6, and when you work that out, you get 0.4. Now I want you to notice how that 0.4 is exactly the same as the original probability of raining. So before we even worried about this hitting the bullseye, the probability of raining was 0.4. And even though we did hit the bullseye, the probability of raining has not changed. So then that tells us that these events are independent because me throwing a bullseye and getting a bullseye on the dartboard has not changed the chance of it raining. Now let's make things a little bit more formal. So this calculation that we worked out here was the probability of raining given that we hit a bullseye. So in mathematical notation, this is the probability of A given B. So given that we hit the bullseye, what is the probability that it rained? And what we identified was that this conditional probability was equal to the original probability. So that tells us that these events must be independent. And I also want you to notice how this probability is equal to this over this, of course. And notice how this number was the intersection over the probability of B. So everything on the bottom was 0.6, which was the probability of B. So the intersection over the probability of B, and actually you get this formula in your formula book, right? So the probability of A given B is equal to the intersection over this event here, the last event there. Sorry, I'm running out of room a little bit here, but what I can say is I can say that now we know that this thing is the same as this fraction, we can say that this fraction is equal to the probability of A if it's independent, and now you can times both sides by B, and so we now get that the intersection probability is the probability of A times by the probability of B for independent events. So that's the reason why if you times these two probabilities together and if you get this intersection, it means they're independent, because it all stems from this calculation here where we say basically if the probability of A has not changed after this event has occurred, it means they're independent. I really need to emphasize this because I see this mistake a lot, right? You cannot work out the intersection probability in general by doing probability of A times probability of B. You can't. You can only do that if they're independent. You can only do that if they're independent. Because if they're dependent, it's nonsense, not true. It's only true if they are independent. So you've got to see that word independent in the question. Hope that helps.